Welcome to C Programming Tutorials. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. If you haven't subscribed to the channel, I would recommend that you do so, so that you can be notified of any tutorial that I post, and I would recommend that you become the fan of the Facebook page as well. Now in today's tutorial we are going to learn about how to pile plates. Well, yeah, I'm not joking, really. So let's see. So you have a bunch of plates. What do you do with that? You basically put them on top of each other like this, right? Pardon my drawing here. But you know, this is the like a cross section of all these plates, and my plate size is getting smaller and smaller, but you got the idea. I mean, this is how you normally pile plates on top of each other, right? Now what do we call it? We call it a stack of plates, right? Now what do we do? I mean, if you think about it, what did we do here? We basically had plates and we put them on top of each other. Okay. Now if you need a plate to take out of that pile or stack, what do? You basically take out the one which is on the top and pull it out of the stack, right? I mean, normally that's what, you know, if you are a sane person, that's what you do. You would never try to pull one out from here, because it's not impossible, but it's very hard to pull the plate from the middle or from the end, or so on. So we basically whenever we need a plate, we basically pull it from the top. The thing is that the plate which is on the top is the last plate that went inside this stack. Okay, so this is the thing about stack, is that basically whatever the order in which you placed, you basically take them out in the reverse order, and this is called last in, first out. Okay, LIFO. This is what it is referred to normally. Okay, in short. So last in, first out. So last plate that went in is the first plate that's going to come out. Okay, now compare it to, say, in some grocery store, or you know, in some departmental store or something. You have a person who is checking out your stuff. Okay, and there are persons here, customers in line, who are trying to basically get their stuff checked out. So this guy is the first person who came in, then this guy is the second person, then third person, and fourth person, and they are in line. And when this salesman is available to check out this stuff, the first person in line goes in here and gets serviced, and when he goes out, the second person in line comes, and so on, right? It's very similar to these plates, except there is one big difference. The big difference is that this is the first person who came in, this is the last person who came in. The first person who came in is the first person who gets serviced. The last person who came in is the last person to get service. Here, the last plate that got into the stack is the first plate that got out. So this is last in, first out. This is first in, first out, which means that the first person that gets in line is the first person that gets out. Now, why are we learning about grocery stores and the plates and stuff? Well, these are the practical examples that we see, everyday examples that we see around us. In computer science, a lot of times the way we accumulate data follow one of these models. Okay? If it follows this model, we say that you have to represent, I mean, this, if you can identify which model it follows, you can identify how to represent that data. or whatever events that are happening, whatever it is, if you see that it's basically, if it is following last in first out rule, then what you have to do is, right away that you treat them as these plates, and the best way to represent this is called stack. Okay, as in our regular language, in natural language, you would call it a stack of plates. That's where it comes from, obviously. So a stack, it means that it's being represented by the data structure stack. And what it means is basically, if anything that follows this rule, you can represent it to the same way as you would represent this ordering of these plates here, the way the plates go and the way the plates come out. Okay, and this data structure, the structure that actually implements the FIFO principle, is basically a queue, or we call it line. We don't call it line in computer science. This structure is called queue, but in our regular language we call it line. So it's basically, it's like, if you have data that needs to be processed in the order in which it came in, the first data that came in, that's the one that you have to process, then it's following FIFO rule here. Some people call it FIFO also, so it's totally up to you. Similarly, some people call it LIFO also, so it's totally up to you, whatever you want to call it. But the point is that this represents a data structure called stack, okay, and this represents a data structure called queue. Now, what would be the examples of a stack? Very relevant example of a stack. Look at the function calls, okay, very closely. And that's the reason why I'm talking about stack here. The function calls, actually, if you think about it, the way they work is basically, this is our main function, right? Remember, main is also a function. This is our start function, the very first function. Every C program has to have a main function here, okay? So this is the main function here. It calls, suppose you basically call some function. Oops. If this is a main function, you basically call some function in here. For example, get ch. Okay, when you call that function, it's like this, right? You call this new function, get ch. And suppose we have no idea what get ch calls, because this function, we never wrote that function. It comes with this compiler. So suppose this function also calls some other function, okay? And then that function calls some other function, okay? And then this function returns without calling any other function. When it returns back, we come back to this function. And then this function returns, we come back to this function, and when this function returns, we come back to this function. So if you look at it, what's going on here? It basically, we are calling this function, then this function calls this function, and then this function calls this function, and the first function that completes is the function that was called last. So this function was called last, this completes first. There is no way that these functions can complete unless this function completes first. So clearly we have, what do we have here? The last function completes first. We have this LIFO organization here, the LIFO trend here, last in first out. The last function that's in, that's the one that would be called, that would finish first. So why I'm talking about this? Every function has some local variables here, okay? So these local variables are actually created on stack. A part of memory which is organized as a stack. So the very first function, the main function, any variable, local variable that you are going to declare in main function, it will be created, they will be created first, okay? So this will be the main function's variables, okay? Then the function call that it makes, they are created here, and so on. And then as the function returns, as these functions return, their memory is cleared. This is cleared, then this returns, it's cleared, and this memory is available for the subsequent calls to the other functions. I'll stop here. Thank you.